The third quantum number we're going to talk about is the magnetic quantum number, or m sub L. This is to give you the orientation in space, or that third dimension. So this is actually going to give us orbitals. So there was N, which will give us shells, L, that will give us subshells, and now m sub L will give us orbitals. There are different formulas you'll see with m sub L. The most common one is this 2L plus 1 that tells you how many values of m sub L there are. The main advantage to that is if you have a value of L and the question asks you how many orbitals are there for a particular value of L, that little formula will give you that answer. But the way that you get the values of m sub L is you basically take negative L to 0 all the way to positive L. So for example, if we were in an n equals 2 shell and we were talking about the L equals 1 subshell, we would technically be in the 2p subshell. Then there would be a variety, there would be 3 values of m sub L, negative 1, 0, and positive 1. And we could specifically talk about where n equals 2, L equals 1, and m sub L equals 1 being the 2px orbital. So this is one of those things where you have to start with that value of n, then your value of L, then your value of m sub L. So quantum numbers seem to get more complicated the further you go, just because everything ties back to other parts of those quantum numbers. So it's very difficult to talk about just the m sub L quantum number when m sub L relies on L, L relies on N. So they all are connected to each other. So if L equals 1, we could talk about m sub L. So again, we talked about that being m sub L being equal to negative 1 and 0 and positive 1. These are the orientations in space. So when you talk about L equals 1, that is the dumbbell shape. Or the p orbital, but there's different ways it can be oriented in space. So that can be along the x-axis, the y-axis, or the z-axis. So you have different orientations in 3D space, which is how you get your different values of m sub L. But there is kind of a fun game with how do we get these shapes, and the short answer to that are nodes. Nodes are something that we don't traditionally test over, but are often fun to talk about and look at, as that'll give you a better idea of how we get these different shapes. So as we go on with shapes, they get more complicated. So when you talk about d orbitals, this would be an L equals 2 to get the d subshell. And when L equals 2, you're then going to have 5 options for m sub L. Most of these are also different orientations, but you'll see that one of them is a completely different shape. So you do get things more and more complicated as we go on. So again, historically, we will usually hold you responsible for the shapes of S, P, and D. So here's D. We saw P previously. S you can look at a different one. And there is a kind of a fun website down at the bottom. If you've never seen Orbitron before, it's a really fun website to play on. It definitely has more things on it than you need, but it definitely has a lot of really fun pictures to look at. So this hopefully gives you a better idea of m sub L, how it relates to L, how you can find it, and what it is. It is that quantum number that's going to give you an orientation in space.